Up next, the Honorable Jared Isaacman, Administrator of NASA, will give a presentation on the future of American leadership in space. But first, please enjoy the following video.
Good luck. Godspeed, Artemis II. Let's go.
For 10 days, the world watched in awe as Artemis II went higher and farther than any humans in history.
Today you've made history and made all America really proud.
For 10 days, Reed, Victor, Christina, and Jeremy inspired the world and captured the imagination of billions. 8.8 million pounds of thrust launched the Integrity spacecraft out of the atmosphere to the moon, around the far side, and back home safely, hitting a velocity of over 24,000 miles per hour before deploying parachutes and splashing down in the Pacific. And we're just getting started. Welcome to the Artemis generation.
Okay.
Oh, did they do the video? Oh.
Yeah.
Good morning. Good morning, and thank you all for being here. You know, just a few weeks ago, in the year of America's 250th anniversary, the Artemis II crew traveled further into space than any humans in history. The world took a brief break from the discourse to witness 4 amazing astronauts journeying around the moon and returning home safely. It was the opening act in America's return to the lunar surface, and we are already well on our way to what comes next. So right now, Artemis III is being assembled at the Kennedy Space Center. Just last week, the Space Launch System rocket core stage arrived at Kennedy after traveling on a barge from NASA's Michoud Assembly Facility in New Orleans. And core stage assembly operations are already underway now in High Bay 2 of the Vehicle Assembly Building. At the same time, teams will begin stacking the solid rocket boosters while engineers continue preparations on the Orion spacecraft, including temporary installation of the solar array wings ahead of deep field acoustic testing. When ready next year, Artemis III will go into low Earth orbit to test interoperability with the commercial landers. Then, in 2028, Artemis IV will finally return Americans to the lunar surface. But this time, we are not going back just for the flags and the footprints. This time, we are going back to stay. So thanks to the vision of President Donald Trump, the Artemis program is a long-term campaign that will see continuous and affordable missions to the surface of the moon, to the moon base, for decades into the future, because America will never give up the moon again. We are moving with urgency because leadership in the high ground of space matters. The scientific, economic, and strategic potential of the lunar surface is enormous, and the United States intends to lead alongside our international allies and commercial partners. Even as we return to the lunar surface and build the base, we will continue to invest in the technologies that will carry humanity even further. That's why NASA is developing SR-1 Freedom, the first nuclear-powered interplanetary spacecraft. This spacecraft is the next giant leap capability and an example of NASA recalibrating to the near impossible what no other company, agency, or country is capable of accomplishing. SR-1 Freedom will establish flight heritage for nuclear systems in space, create the regulatory and operational precedent for future missions, and help activate the industrial base needed for long-duration exploration. When Freedom launches in 2028, America will finally get underway on nuclear power in space. Once at Mars, the spacecraft will deploy the Skyfall payload of Ingenuity-class helicopters to continue exploring the Red Planet and prepare for what comes next. All of this, Artemis, the moon base, nuclear power, SR-1 Freedom, are part of one grand vision of American spacefaring future that will keep us first in space and inspire the next generation to go even further. A future with multiple moon bases, commercial stations in orbit, nuclear-powered spacecraft, octocopters on Saturn's moon of Titan, new telescopes in orbit, and eventually manned missions to Mars, and it's being built right now. This is the most exciting period in space exploration since Apollo, and we are just getting started. Thank you.
Now, please welcome Major Megan Hainline, Air Force Fellow at SCSP, who will moderate the discussion with the Honorable Jared Isaacman, Administrator of NASA.
Administrator Isaacman, it is an honor to welcome you to the stage today. We are at an incredibly exciting time for NASA, for space exploration. The theme of this conference is America at 300, in 50 years from now, celebrating our birthday. If you could, as we start out, imagine for me we are in 2076. What does the American footprint across the solar system look like?
Yeah, what a great question. Well, I'll tell you, we will know an awful lot more outside of our solar system. So by then, not only will the Habitable Worlds Observatory be online, but I would hope several subsequent versions of that telescope, which is specifically designed to look at exoplanets outside of our solar system in the Goldilocks zone and look for biosignatures. So I would say we'd know a lot more, again, about star systems and potentially habitable worlds outside of our own solar system. Now, to maybe some of the, the more human connection to things, for sure you have multiple commercial space stations that are being used for advanced manufacturing, whether that be in biotech or other potential commercial applications, whether we're 3D printing organs or making, crystal formulations for cancer-fighting drugs. You for sure have your lunar outpost. Now that we're going to begin establishing in early 2027. You'll see a near monthly cadence of uncrewed robotic missions to the lunar surface. That's phase one of a multi-phase plan. It's going to start with a lot of littles to learn and inform semi-permanent habitation until you eventually get to that enduring presence where you will, endeavor to pursue scientific pursuits, the economic potential of the lunar surface, so a lunar economy. But really, it's the technological proving ground for what comes next, which by this time period we will have surely delivered upon, which is putting crewed astronauts on the surface of Mars. So we're actually not that far away. Call it a 10 to 15 year time period before to be able to undertake such a mission. The hard part is getting them back home, and a high likelihood of having to make your own propellant on the Martian surface. So we'll use the moon to be able to do that. So by that time period, we will probably have near routine operations, almost assuredly under nuclear power as well, for sending astronaut missions to Mars. And again, why would you ever give up your lunar outpost? Because it is such a great scientific proving ground, tech proving ground when you're only days away from home. Will we have ventured out farther than Mars by that time period? I don't know. It's a good question, but for sure I would say we'd have multiple outposts operational on Mars by then. Incredible.
Let's talk a little more about how we get there. So you've mentioned nuclear. We've got Space Reactor 1 Freedom going to Mars in, I believe, 28. You've got the Dragonfly going to Saturn's Titan. Is that the breakthrough scientifically that we need to make Mars a reality? And is it fundamentally different science, a breakthrough in science, or is it really society's acceptance of nuclear power and interest in it that is changing?
Yeah, so it's a very good question. I do think society has come away from kind of this Chernobyl-like impression of all things nuclear and realize, you've got a lot of good, a lot of energy density there that we can unlock and apply across a number of applications, whether it's to meet the terrestrial energy demand that's going to be needed to win the AI race, but certainly when you're in the permanently shaded regions of the moon where you're going to build a moon base, you're going to want to rely on nuclear power. If you're going to have to make your propellant on the surface of Mars to be able to come home, you're definitely going to rely on nuclear power. It's either that or lots of football field sizes of solar power with robots going and dusting them off all the time, which is not out of the question, by the way, as a possibility. But then the ability to efficiently move mass to and from Mars is where you're going to want nuclear power. And SR1 Freedom is nuclear electric propulsion. It is absolutely the 70% solution. This is the Nautilus that was originally meant to be a diesel boat. But it'll help get America underway on nuclear power in space for what will come next, which is you want to start getting into an iterative design cycle, improving power conversion efficiency, higher temperature materials to minimize cooling, radiator requirements. and just gradually continue to increase performance. In parallel, you're going to want to also work on its breakthrough capabilities for us, but we actually tested it in the 1960s during a different time, which is nuclear thermal propulsion. So nuclear electric propulsion is you're trained to move lots of steel across the country, if you will. It's not the fastest way to go, but very efficient. Nuclear thermal, that's your Concorde. That's how you get to Mars very, very, very quickly. So we got to start somewhere. That's what SR1 Freedom is about. It is going to be that pathfinder, but you're going to see lots of applications, I think, from the national security side to the lunar-based power source to eventually power source on Mars, not to mention the ability to just explore the outer solar system itself. You're going to want to rely at some point on nuclear power, just given the effectiveness of the sun past Jupiter is pretty minimal.
Looking at the commercial side, so you're the first administrator of NASA who's commanded private space missions and extensive experience in the commercial space sector. How are you fundamentally changing some of the business practices at NASA to bring in some of those lessons from commercials? You're looking at really aggressive timelines with Artemis and a moon base and all these other things. What is the best takeaways NASA can get from commercial? And then vice versa, what does NASA do really well that you think commercial could learn from?
Okay, so there's a lot there. I would say the fact that I've been in space twice is helpful from understanding maybe a greater appreciation of the risk. But I would say, and I've said it many times leading up to those missions, it's the entire experience on the ground with literally the army that it takes to pull off these kind of missions. So everything from the design process through development, we worked and built a EVA suit on Polaris Dawn, having an appreciation for what all those teams that come together in order to make something possible for four individuals. I think that perspective was very important. And obviously commercial's approach is a little bit different than NASA's, which if it's being calibrated properly, it should be a little different. NASA should be doing the near impossible, taking on some of the most challenging engineering problems imaginable that does not have an obvious business case for industry, something that, again, no company, nation, or other government agency should ever take on. But there is a blend here, right? For example, I mean, in the commercial world, generally, you'd have a board of directors and a chief executive officer that wield incredible influence to drive direction and outcomes very fast. Can't afford not to get to outcomes because the check is not guaranteed to come to fund the operation like it might be in a government agency. So there's a lot of good there in that's helpful. But then there's process rigor when you're going into, no-fail, incredibly challenging, again, near impossible endeavors where some of the government structure is beneficial. The big difference, I would say, is just the extensive amount of stakeholders that are highly opinionated in government operations, and that's everything from both chambers of Congress to industry that all love what we do at NASA, but may have different approaches to how you achieve it, different directions. And that I find between my business background, not just in aerospace or what I've seen in commercial space industry, but just normal business background of trying to get everybody aligned around a common objective. I think that's been, I think having that background has been very helpful because for a long time at NASA, we did try and, when we were, absent competition on the geopolitical scale, which we certainly have today, we tried to do a lot of littles and let everybody kind of impose their various views and directions, not to mention some self-inflicted ones that we came up with ourselves. And as a result, you accomplish very little. And now we're kind of bringing everybody together and getting refocused on the mission, which is what's outlined in the President's National Space Policy: return to the moon, build the enduring presence, and prepare for what comes next, which is Mars.
I'd like to dig a little more into the incentives and goals side of that with the commercial side of things. So you've stated one of your goals is to ignite the space economy. The ISS is scheduled to deorbit in 2030, and the plan is to have commercial labs and an orbital infrastructure on the commercial side, maybe with some civil modules or NASA modules added onto those. Are we on track? Is commercial side actually on track with the incentives and with the funding in place to build that infrastructure out? And where is NASA's role in helping support some of that and the private-public partnership side? How do you envision that in the next decade?
Well, we're trying to address it as quickly as we can because it is covered in a national space policy. So the same national space policy that the President signed on my first day on the job of returning to the moon, the base, the nuclear program, does call for a transition away from the International Space Station, or at least to begin it by by 2030, which makes sense. It's been an unbelievably well-performing laboratory for more than a quarter of a century. We should continue to invest in and ensure we have the latest capabilities in low Earth orbit, because it is a great environment for microgravity research, even as a tech proving ground as well. We'll test the lunar spacesuits that our astronauts will take to the surface of the moon on Artemis IV on the International Space Station later this year. So we do want that presence. What we're working through is making sure we have the right funding dynamic between what NASA will be able to provide to industry versus what others will be able to. As it's envisioned today, NASA will be one customer of many. So it's very important for us to get our arms around that. We put an RFI out to industry to say, help us understand what other sovereign nations are going to provide, if commercial industry, is big pharma coming in and funding a lot of this, so we can get the complete picture and make sure we set up the plans correctly. Because to be quite honest at NASA, we haven't done a good job of assessing markets in recent history. We haven't done a good job of staying on budget and on schedule. And I think when it comes to America's presence in low Earth orbit, we don't want to get that wrong and risk a gap, because then the only other station that'll be up there is the Chinese space station. So we're working with industry. We have the executive order, and we are going to, and we're also working with congressional stakeholders and such to make sure we set up an achievable plan to transition to for when it's time to sunset the station and go to commercial approach.
So that's actually a great segue into my next question about the Artemis Accords and international cooperation. So Artemis Accords now has 67 signatories after Paraguay just signed yesterday.
It's been a great week.
So nations that have agreed to peaceful space exploration, to sharing scientific information, to sharing spacecraft positional data and activity information. Notably absent, though, are China and Russia. And they have announced a collaboration on a international lunar research station. So how do you approach finding common ground and finding common values and setting norms, governance, mineral rights in the space sector, while also acknowledging that there's very real geopolitical competition happening?
So what a great question, right? The Artemis Accords do set a foundation of common principles for how we should conduct operations in space. The peaceful exploration of space, we're all very like-minded in that regard. But when it comes to things like avoiding creating needless debris that could be a hazard for commercial operations, for civil, scientific missions and such, it's not always that helpful if the two nations that have the ability to manage it are not not Artemis Accord signatories. Mm-hmm. And we have these conversations. In fact, I was with Ambassador Waltz, at the UN, when he was very kind to host the Artemis II crew. I want to say just last week. We've been rather busy of late, and we've had these conversations because he, at the UN has a great forum to raise these points. That yes, it's the Artemis Accords signatories are doing a fantastic job of the kind of responsible exploration of space, but we need to bear in mind the other countries that are not signatories and how they're conducting themselves, and that's what the State Department and our foreign policy, and again, Ambassador Waltz would take up those causes. But what I will point out, as the Artemis Accords continue to grow with member nations, is that we are going from principles to practice now, which is great. So as we announced the moon base construction, instead of jumping right to the glass dome, the moon base as a service, with the Ferris wheel and the crop farms and such, we are drawing on the playbook from the Apollo era of going from Mercury to Gemini to Apollo and do it in an iterative way and learn, because we haven't been to the moon in a long time. It's an incredibly challenging environment to go in. And as a result, we are forecasting dozens of landings to the moon. We'll probably spend close to $20 billion over the next 7 years just to build out the first phase of the moon base. And when you have a near monthly cadence of landers and rovers on the moon, like we do not have enough scientific instruments across all of NASA's centers to maximize the mass and volume payloads on those landers and rovers. So what did we do? We went to the Artemis Accord signatories and said, go talk to your university students. Who has hardware that you're willing to contribute? So you think about it, of those 67 nations around the world now, they have students in university that is working on hardware today that probably in the next 2 or 3 years will be on the surface of the moon. Same for all the American universities as well. So what a great environment now to go from what we all agree to as the best practices for operations in space to now putting it in practice and saying let's contribute to the scientific and the economic breakthroughs that we know know are inevitable on the moon. And surely there will be other great projects that we will be able to do as a coalition of Artemis Accord nations in the years ahead as well.
So there's a lot of excitement around space, but the first day in NASA is aeronautics.
Yes.
So I'd like to talk a little bit about that. The X-59 and the NASA's Quest mission are looking at quiet supersonic flight for commercial purposes. What can you tell us about kind of where that program is at, and then kind of the follow-on, do you foresee that being something that unlocks travel for the average person that would be able to be much faster at supersonic speeds, or is it going to kind of stay in a niche luxury travel business jet kind of level for quite a while just based on cost? Do we need other breakthroughs in propulsion and drag reduction to make that happen?
Well, it's a good question. I would say that the aeronautics portfolio is one that I went into this role with high expectations, a lot of enthusiasm. Turns out there was some work to do. We are making great progress. X-59 had flown once and was in depot maintenance when I was sworn in. Now it's flying, I want to say, almost every other day. We've done 2 goes in a day as of rather recently, and we're just about to move into the supersonic expansion of the flight envelope for the aircraft. So we're getting back into a good rhythm of flight test. We're also rebuilding core competencies. We had outsourced a lot of our flight test abilities over the years, as we did across the entire NASA agency, and so that is part of a broader workforce initiative to bring back some of that experience inside the agency so we can undertake programs like X-59, but not over decades. Like, these are programs you want to have multiple in parallel underway and to get through in years, because you know whatever X-plane you're going to work on next is going to be that much more exciting. So that said, where is X-59 going to take us? Will it directly lead to supersonic transport over the U.S.? I don't know, right? I mean, almost to your question before on commercial space stations, is we can do what we can to try and ignite an economy. We can't necessarily always close a business case in that, so we will gather the data from this flight test program. We'll always make it available to industry. Industry will have to determine, hey, is there a good business case to build a Mach 1.4 quiet supersonic transport aircraft? Is there going to be enough people that want to either pay for the aircraft or buy seats on it? Or do we need to go faster? And I'd argue, with most of the corporate jets now in the high subsonic, 0.975 type regime, you probably do need to go faster to really make it the incremental cost and upkeep worth it. So we should be working on that too. And that's why we're trying to expand our portfolio of platforms, similar to decades past at NASA, where we had multiple X-planes that contributed to commercial transport, national security reasons. Go to a lot of air shows today, you're certainly seeing capabilities that NASA helped pioneer in decades past, and trying to rebuild some of that those muscle memories that have atrophied over the years.
And speaking of the workforce and just the overall excitement, obviously Artemis missions have really recaptured the nation's imagination. There's so much excitement around it. How do you transfer that into motivating the next generation of engineers, scientists, your pilots, your astronauts, and have them see it as a call to service and a call to NASA, and keep NASA as that shining place people want to work, especially when you've got a lot of commercial growth on the private side that they could also be drawing some of that talent. How do you keep that talent at NASA?
Yeah, well, I would say, that's a big question. I know we've like seconds to go on this. Just say we're partnering with Scott Cooper at the Office of Personnel Management. He's been incredibly supportive of all of our various initiatives. The cultural changes that are underway at NASA, where we are refocusing on the mission. What's the best way to create more engineers, scientists, pilots, and astronauts that want to grow up and contribute to this great endeavor? It's to focus and execute well on the mission. Good outcomes. Artemis II. More kids are going to dress up as astronauts for Halloween after Artemis II. Certainly on Artemis IV, when those astronauts return to the surface of the moon. Building a moon-based website so people can see us constructing this in near real time. Flying more X-planes with greater frequency over big events, is a great way to get people to look up and be inspired in between major rocket launches. So we're focusing the agency back on the mission and delivering outcomes with with urgency right now to inspire the next generation. We will then kind of get them hands-on in school through over $1 billion a year in various grant programs, helping build the moon base, as I described before, with hardware. And then we have lots of great internship programs to bring them into the agency. And then how do you retain them? So, because if they move on to industry, which is absolutely a fantastic outcome, but how do you not compete with industry by working again, recalibrating on the near impossible objectives like nuclear power and propulsion spacecraft, where the only game in town, if you want to do it, is NASA. And that's how I think you attract and retain some of the best talent, not to mention achieve really world-changing outcomes like sending astronauts to Mars.
All right, I think that's an incredible note to end on. Ladies and gentlemen, please join me in thanking NASA Administrator Isaacman for being on the stage today. Thank you so much.